Right, question 2 of the assignment gives us a curve y equals 9 minus 6 over x and a line y plus x equals 8, and we're asked to find the intersection of both, that it intersects twice, and we're asked to find the intersection of both. The easiest thing to do would be to rearrange one of these equations so that you might get what y equals in terms of x, or the other way around. So we'll get y equals 8 minus x. We can now substitute that into y. So we're going to start with y equals 9 minus 6 over x, and we're going to substitute that y to be 8 minus x from this equation here. Now I could tidy this up, I can make it equal to 0, but I'm still going to have this x on the denominator. So if we multiply through by x, we can get rid of that, and now we can collect some like terms. So let's move everything to the right so that we'll have our positive x squared come through, and we'll have plus x minus 6. Now when we've got this equation, x squared plus x minus 6 equals 0, we can look now for the solution either by factorising or by using the quadratic formula. In this case it's probably easiest to say x plus 3 x minus 2 and do it by factorising. Gives us the solutions that x equals negative 3 or x equals 2. Now those are the x coordinates, and the question asked for the coordinates of the 2 points. So points also have y values. So we need to say when x equals negative 3, and we'll use this equation here for y equals 8 minus negative 3, so y equals 11. When x equals 2, y equals 8 minus 2, or 6. So therefore 2 points of intersection are at our two values of negative 3, 11 and 2, 6. And that's it, done. Question 3 gives us this diagram which represents a window, and we're told that the perimeter equals 8 in the question, and we're asked to express h in terms of r. So that means getting an expression that says h equals, and it'll involve some r's on this side. So we need to form an equation with the information we've got, and we've got some information about perimeter. So looking at this diagram and coming up with an expression for perimeter, we'll have that perimeter equals h plus 2r. So 2h plus 2r, and then we've got this piece on the end, which is, and we're told in the question that this is a semicircle. So we know that 2 pi r does the entire circle, so 2 pi r, but we're only having half of it. So in other words, the perimeter is 2h plus 2r plus pi r. And now we want to rearrange so that we can get h equals. We know that the perimeter equals 8. So now just getting h by itself, we'll have 2h equals 8 minus 2r minus pi r, and then h will equal all of that divided by 2. And we could simplify that up a bit so that we'll have 4 minus r minus a half pi r. So remember that this 2 on the denominator needs to divide into each term in the numerator. So the 8 is divided by 2, so is the 2r, and so is the pi r. And there's our first part of the problem. The second part says that show that the area is given by the expression 8r minus 2r squared minus a half pi r squared. So we need to come up with an expression for area. So an expression for area, given the shape that we've got, would be 2r times h, so that's the base times the height of our diagram, and then we need to add in the top of the circle, or the semicircle on the top. So we know that semicircles, the formula for a circle is pi r squared, and we want half of that. So here's our formula. We also know an expression for h because we worked that out at the end of the first question. So now we can have 2r times that expression that we worked out for h, and then we're going to subtract add, should be adding that, add the area of the circle on the top. So we have pi r squared all over 2. And now we just want to simplify it up. We're heading to this answer hopefully, and that's what we want to show right at the very end. So we've got 8r from this bit, we've got minus 2r squared from this bit, and then if we multiply our 2 and our half together, then that cancels out and we're left with pi r squared, and then we're adding pi r squared over 2. I'll just run out of room on my page. So if we simplify this up, we should be at our answer of a equals as in the question. So we've got our 8r, this is looking good. A equals 8r. We've got our minus 2r squared, great. And then this end piece, we've got negative pi r squared, and then we're adding half a pi r squared. So we'll still be left with negative half pi r squared, and that's what we wanted. So we've achieved the outcome that the question wanted us to get to. Question 4, the first part asks us to show that the whole of this curve lies above the x-axis. This is quite similar to an earlier question when we did, it was question 1 part 2 of the assignment, where you had to show the set of values that were greater than a particular value, because here really you're saying that you want this to be y values that are greater than or equal to 0, in fact greater than 0, because you want it to be entirely above the x-axis. So you could do it by graphing this, and if we want to graph it, the easiest thing to do would be to get it in the completed square form. So if we start with that, y would equal x minus half of 3 over 2, and we'll square all of that. Now again, we can do a little side calculation to make sure that what we're getting is close to what we need. X minus 3 over 2 all squared is going to give me x squared, and it's going to give me minus 3x, which is great because that's what we want, but then we're going to end up with plus 9 over 4 at the end, with our 3 over 2 times 3 over 2 getting multiplied together. So we've created this positive 9 over 4, if you like, by accident, but that's fine because we do want positive 4 on the end. So we've got like a little piece here, we've got 2 1/4, so we'll have to have this expression, which is the start of our completed square form, plus 1.75. So now that we've got this written in completed square form, it's now easier to see where the vertex is. So we can say that the vertex will be at 1.5, 1.75. And this is a positive parabola. So we now know that the minimum value for y is actually 1.75. So therefore, entire graph above x-axis. Now of course in an assessment you'd be wanting to write this out in full sentences instead of abbreviated ones, but that point is the same. You've found that the whole thing's above the x-axis. Part 2. Part 2 says that we've got the equation of a line y plus 2x equals k, and it tells us that k is a constant, and we're looking at the case where k equals 6. And now we want to find the coordinates of the intersection between the line and the curve. So here's our curve here, and this is our straight line. So once again we can just rearrange so that we've got y values, an expression for y, and we've got y equals x squared minus 3x plus 4. So we could just equate the two expressions together. So that means that x squared minus 3x plus 4 is equal to 6 minus 2x. Now I need to tidy that up and set it equal to 0 so that I can begin solving. So x squared, and we're bringing that across, so we have minus x, and we're bringing the 6 across, so we'll have minus 2 equals 0. And hopefully again this will be a nice easy one to factorize, but if it wouldn't, then we can go to the quadratic formula. So looking at these, we'll have x minus 2 and x plus 1, which means we've got x is 2 and x equals negative 1. Now again, we know that x coordinates aren't points, they're just x coordinates. We need to find y values by substituting in. So when x equals 2, y equals 6 minus 4 equals 2, when x equals -1, y is going to equal 6 times -2 times -1, or positive 8. Therefore, points of intersection are 2, -1, and 2, 2, and -1, 8. And there's our 2 points as they asked for in the question. We could also do it by drawing a graph and seeing where the two intersect.